Hello, this is our second section on how neurons work. In the first section, we talked about the parts of a neuron and the function of a neuron. In this section, we're going to focus more on the details of how a neuron works. Now at rest, cells pump sodium, which is Na+, out of the cell, and potassium, which is K+, into the cell. Once the sodium is in the cell, it can't leave without the cell using energy to pump it out. But on the other hand, the potassium, once it comes in, can go out. So between the sodium leaving and the potassium leaving, the axon has a net negative charge. Now to make this a little easier, we're going to pull up a drawing and show how this works on the drawing. Now on this drawing, this section over here is an example of the axon of a neuron at rest. And you'll notice we'll have two different types of ions. We have potassium, which is a K, and we have sodium, which is Na+. For potassium I'm going to use green, and sodium I'm going to use blue. Now remember that the potassium, the green one, can move both in and out of the cell. So at a resting state, the neuron is pumping potassium into the cell, but these same potassium ions can move out again. Where the sodium on the outside can't come in, and the body is actively taking this sodium and pushing it out. So the body's taking the sodium and pushing it out. This gives us a net negative inside the axon. So when an axon is at rest, the inside of the axon has a net negative charge. Going back to our notes, when a neuron fires, it has an all or nothing response. And an all or nothing response means there's either a full response or no response. It's kind of like turning on a flashlight. When you turn on a flashlight, the flashlight is either at full power and on, or off, and there's no light. So what the threshold of a neuron is simply the idea that a neuron will only fire if a minimum level of stimulation is reached. If there's too little stimulation, the neuron won't fire. There will be no action potential moving down. But if it's above that level, the neuron will fire. Let's talk a little bit about what actually happens after the threshold is reached. So let's say we have a neuron and it's been fired. In this case, fired means that enough stimulus has come through the dendrites that an action potential is going to form. The way that the action potential forms is that the neuron pumps sodium ions, Na+, into the axon. So those blue Na ions will come into the axon. This makes a positive electric charge which moves down the axon. The cell returns, after it's gone past the Na+, it returns to the resting state by pumping out K+. There's a typo that I've highlighted. It shouldn't be in, it should be out. Okay, so the cell returns to the resting state by pumping out K+. Okay, so it's fired by the neuron moves sodium in, that makes a positive charge, and then it gets rid of the positive charge by pumping in K+, which then pulls itself out and it goes back to a negative state. Let's have a visual on this one to make it a little easier. Now we're going to look at a little further down here. Give me just a second. Escape. Let me move the screen down a little so we can see it. There we go. So what we have here, this is the action potential. Let's make that orange. Okay, so this is the stimulus. This is the stimulation that goes over the threshold. And what the neuron starts doing is it starts taking sodium and pumping it into the cell. And on this side we would also have an Na+. can't really write very well, going into the cell. Notice this makes it positive on the inside. Okay? So as it moves down, as this stimulus moves down, it's still a positive sign. And it stays positive because more sodium is pumped in, okay, making the positive charge here. Behind the action potential, the way the body relaxes the neurons or sets it back so it could be fired again is this potassium goes out of the cell. And once the potassium is out, this is a negative charge again. Okay? So at the action potential, sodium goes in, making a positive charge. Behind it, potassium leaves, leaving a negative charge. So that's how the stimulus travels down through the axon. At the end of the axon is the axon terminal. And what the axon terminal is, if you remember, is it's a spread out area and where the electrical impulse, that positive charge, is changed into a neurotransmitter, a chemical. So the impulse triggers the releases of a neurotransmitter, a chemical, into the synapse. The neurotransmitter then, the chemical, moves through the empty space between the neurons and attaches to receptors on the next nerve cell. Can you guess where those receptors are going to be at? They're on the dendrites. Yeah, they're going to be on the end of the cell nearest the cell body. That creates, when there's enough stimulation on that dendrite, the neuron is excited, and that starts up the entire process again. So this is the end of our notes on neurons. If you have any questions, feel free to get a hold of me during class. Have a great time.